Hello friends, welcome to our website automationcommunity.com. Based on your request in the comment section, today we are going to see servo motor control using PLC and HMI. So the aim of this video first of all is to understand the wiring required for servo motor, servo drive through PLC because it is little complex and different from ordinary VFD. After that, we will see what are the necessary parameters, and after that, we will see what are the PLC instructions can be used for servo control. And in the next part of this video, we will see how to design HMI screen like this so that we can control our servo motor through HMI screen, and also its simulation that we will see in the next part of this video. So I have created HMI screen like this. So let us start understanding the wiring required for the servo drive. So this is the Delta ASDA B2 servo drive, and here we will understand the terminal wirings. Now we will see the complete wiring diagram of our system. So as you can see over here, our three-phase power coming from MCB and passing through contactor. So via push button, we will operate this contactor. From the contactor, we will connect choke coil or EMI filter. From that, we will give input power to this drive. And as discussed earlier, we will connect two phase to L1 and L2 for the auxiliary supply of the drive. Now, here you can see the UVW, three outputs are connected directly to the servo motor. Now, there are so many servo motors in the market which has inbuilt encoder. So it will have two connectors, one for the power and another connector or terminal for the encoder. So that encoder will be connected to CN2 terminal, and this is our regenerative braking registers that is connected to P and C terminal of drive. Now we will program our drive through laptop. We are connecting it to CN2 terminal, and all our input buttons or outputs are connected to this terminal block via CN1 connector to this drive. Now what we will connect over here, so as you know, to control the servo motor, we give number of pulse and direction through our PLC and HMI. So outputs from PLC will be connected to this terminal block, and through this terminal block we will connect it to CN1 terminal that we will see later part of this video. So this is the complete overview of our system. These are the basic pin details about the CN2 terminal. This is the pin details on motor connector, and this is the drive side pin details. Similarly, as discussed earlier about this CN1 terminal, so this is how it looks like. All our digital inputs, digital outputs are connected to this terminal. After that, you see this portion. This portion is connected over this, and this connector is connected to servo drive. Now, this is the wiring diagram of our PLC to our servo drive, as it has 44 pins. So here you can see this is the pin number 17, 35, 37, 41, 44, 14. These are the pin numbers in this IO module, and assume that this is the our PLC. Now there are lot of different kind of wiring. So here we have assumed open collector input type of wiring. So what we will do in this, internal 24-volt supply of the servo drive that is available at the pin number 17. So that will be shorted to pin number 35. Now what we will do, pin number 14 of the servo drive, that is providing common. We will take common from here and connect it to common of digital outputs of our PLC. So here you can see both commons of digital output of PLC are connected to common of servo drive. Now assume that Y0 is our pulse output through PLC, so that is connected to pin number 41, which is used for giving pulses. And similarly, Y1 is our direction output for our servo drive, so that is connected to pin number 37, which is the sign pin or sign terminal. So this is how the PLC will be connected to this IO module, and through this it will be connected to our servo drive. There are a lot of other pins also. So what are these pins? So for your reference, I have given, so this is the details of other pins, like there are the digital outputs, digital inputs. This is pulse and sign terminals. Besides that, for speed and torque control, we can give analog input, like we connect potentiometer in the VFD. So similarly here we will give voltage feedback for speed and analog feedback for torque also. And there is the internal 24-volt supply. Similarly here are the other pin details that you can refer over here. Now here we have seen digital inputs and digital outputs. So we will try to understand what kind of digital inputs we can give to drive and what kind of digital outputs we can take from servo drive. So in general, what we do, like there is any CNC machine or any other machine which contains the servo drive. So we take one output from PLC and we connect it to, for some digital inputs, pin number is by default. So first of all, what we do, we give this servo on command to our servo drive. So if we give power at this terminal, our servo drive will be enabled. Similarly, if there is any alarm and if we want to reset that from push button, so we will connect our push button to pin number 33, and by pressing that push button we can reset the alarm if there is any alarm on the drive. Similarly, there is count clear, so it will clear all the pulses. And finally a stop command. So here you can see there is no any specific pin, so you can connect it to any digital input. So these are the important digital inputs that are used in real life applications. Besides that, there are other inputs also, like you want to connect your emergency switch to servo drive, so you can connect it to pin number 30. Similarly, if you want to change the direction of servo drive through push button, then you can connect your button to pin number 32 for clockwise direction. And similarly, if you want to reverse, then you can connect your push button to pin number 31, that is counterclockwise direction. So by pressing this button, you can change the direction of the motor. So these all are the auxiliary things. That means if you want to use in your project, you can use it like this. So this information is for that purpose only. Similarly, if you want to operate the drive in jog mode, so you can connect your button like jog forward and jog reverse. Here also the pin numbers are not specified. That means you can connect it to any digital input. So these are the important digital inputs used in the industries. Similarly, we will understand what are the digital outputs from servo drive that are the used by industries. So first of all, servo ready output, that is by default the pin number 7 and pin number 6 is there. This feedback is used in all the CNC machine or any other machine which uses the servo motor. So in the interlocking, first of all, we will check whether the servo drive is ready or not. So this feedback or this output is taken from servo drive. Similarly, we want to indicate whether the servo drive is ready and on or not. So we can get servo on output from servo drive outputs. Pin details are not defined. That means you can use any other digital outputs. Similarly, we can use this alarm bit. For example, if there is any alarm or fault in the servo drive and you want to play buzzer, siren or indicating light, so you can connect that to pin number 28 and pin number 27. So if there will be any alarm, your output will be energized. So these are the important outputs that are used in industries. Now actually the servo drive or servo system can work in three modes, that are the position control mode, speed control mode and torque control mode. So in this video we are going to focus on position control mode only. So what is the difference? Each mode has different parameters and different wirings. So I will give you basic detail about the speed control and torque control. So as in the image you can see, we have to connect. If you want to control the speed, then you have to give analog 10-volt voltage to pin number 20 and pin number 90. Similarly, if you want to control your torque, then we have to give external 0 to 10-volt feedback to pin number 18 and pin number 19. So this is similar to we are using potentiometer in the VFD. By varying the potentiometer, you control the speed of VFD. So the same thing is happening over here. By varying the potentiometer, you can vary the speed of servo drive, or we can give analog output voltage from PLC to control the speed or torque of the servo drive. But here in this video, we are going to focus on position control, where we give pulse and direction. So when we give desired number of pulses and direction, so that is the position control. So this was all about the basic details for wiring of the servo drive and servo motor. Now we will see what are the essential parameters for servo drive. So first of all, if you want to connect anything to digital input 1, so you have to connect that to the pin number 9, and for what will be the function of pin number 9, for that you have to set the parameter P2 of 10. Okay, so likewise there are other pin numbers and their respective parameters. What are the other parameters? So this is the parameter number P100. In this parameter there are 4 sub parts A, B, C and D. So first of all we will understand the what is A parameter. So A parameter is type of pulses. So we are going to give pulse plus direction. So here by default this is 2. So that is, you can see from here we are giving pulse and direction. So here we have to select this number 2. After that in P100 there is B. B means input pulse filter, because this is the high frequency pulses. So there can be noise, but by default uh, right now we can select 4 in the B, that is no filter function. After that in the P100 there is parameter C. In this parameter we have to select 0 or 1. 0 for positive logic, that is from PLC we are going to give positive pulses. So we have to select positive logic. If we are giving negative pulses, then we have to select negative logic. So this all are the parameters for position control. Finally, in P100 there is last D parameter. So in this parameter we have to select which type of wiring we are going to use. So focus over here. 0 means open collector for low speed pulses. So as you can see our wiring, here you can see this is the open collector input. So this is open collector input wiring for low speed. So this thing we have to select in our parameter E100D. That means we have to select 0 over here. Now there is the important parameter for servo gear ratio settings. So what is this? Let us understand it. It is very interesting thing. Assume that our encoder has 2500 pulses for one rotation, and assume we have given 4 rotations, or 4 rotations has been turned through servo drive, and it has elapsed 3 mm of distance that you can see over here. Here you can see this is 1, 2, 3 and 4. So servo drive has turned 4 times, but it has covered 3 mm of distance. Now we have to do gear ratio settings. So by default the gear ratio setting is 1/1. So now what we will do, we have to convert this 3 mm into micrometer. Okay, this is 3 millimeter to micrometer. So we have to multiply it through 1000. So you can see 3000 micrometer means 3 millimeter. So we have just converted this mm to micrometer. Now as I said, it has turned 4 times. So how many pulses we have given? So here you can see 4 turns and 2500 in each turn. That means 10,000 pulses. It has moved 3000 micrometer. So what we have to do? We have to make this 1. Assume that if we multiply this with its reciprocal, that is 10,000 divided by 3000. So it will cancel out each other, and what we will get? We will get 1 over here. So what this 1 represent? That means if we give 1 pulse, then this servo system will travel 1 micrometer. So it will be easy for us to convert our pulses into distance. We can easily write the code. So for this purpose, we do gear ratio settings. So for this, we have to give numerator. So this will be our numerator. This will be our denominator. So we have to give this to our servo drive parameters. So in the P1 of 44, we will enter the numerator, and P1 of 45, we will enter the denominator. Now we will see the PLC instructions that can be used to control the servo drive or servo motor. So basically, there are 5 types of instructions that can be used to control the servo drive or stepper drive. So let us discuss what is the difference between each and where we have to use which instruction. So first of all, there is DPLSY or just PLSY command. So by using this command, what we will do, we give number of pulse and frequency to our output Y0. But if you want to change the direction of servo drive, so that bit we have to change separately. So from this instruction only we can't do that. Now in the DPLSV, we can only give one input, that is frequency command only. We cannot give number of pulses. So what is the meaning of the number of pulses? For example, our servo drive is moving one revolution for 1000 pulses. So that means if I give 2000 pulses, it will turn for 2 rotation. If I give 5000 pulses, it will turn for 5 turns. But in PLSV, we can only give frequency only. So what is the use of frequency? Frequency is kind of speed. If we increase the frequency, the speed of drive will be increased. If we decrease the frequency, speed of drive will be decreased. So in some cases, we want to on off our servo drive based on proximity sensor or limit switch. In that case, number of turns is not important. Speed is important. So in that case, we can use DPLSV command, and where the number of turns or specific position is important, at that place we can use DPLSY command. Now coming to DPLSR instruction, we can give three inputs. First, pulse number, after that frequency, that we have already discussed. What is the third command? We can give acceleration and deceleration time also. In some applications, we want servo drive to start slowly and after that it picks up the speed. So in such applications, we can use DPLSR instruction. Okay. Now last two instructions, that are DDRVI instruction and DDRVA instruction. Let me explain you like this. We are trying to understand DDRVI. First, let me draw for DDRVI instruction. Let us assume first time I am giving 1000 pulses. So what it will do? It will travel for 1000 pulse. Okay. Now second time I am giving 1500 pulses. So it will travel for another 1500 pulse. What is the total travel distance? That is the 2500 pulse. This is for this instruction. Okay. Now in this instruction what happens? Let us assume first time I am giving 1000 pulses. So it will travel for 1000. Now next time I am giving 1500 in the input number of pulses. So what it will do? It has to go to 1500, that is here. Okay. So it will travel only 500. It will travel only 500 pulses. So here total distance covered is, or total movement done is 1500 pulses only. Now if I write go to 2000, so what it will do? It will start from here. If we have to go to 2000, what it will do? It will take its initial position to here. From here it will go to 2000. So what it will be? It will be movement of 500 pulses only. So this is the difference between DDRVI and DDRVA instruction. Now in this video we will see how to write this instruction in PLC, and in the next part of this video I will design HMI screen like this. So now I will open my ISPsoft software from here. We will click on the new file and we can write name of our project. You can select your model number from here and click OK. First of all, let us write the device command list. Let us say M0 is our start 1, start 1 and M1 is our start 2, because we are going to use two commands dplsv and dplsy. So for that, y0 is our pulse, number of pulse, y1 is our direction. So we have only two outputs and we will use data registers. Let us say D0 is our number of pulses, D2 is our frequency, D4 that we will use from HMI. So that will be our sys from HMI. D6 will be our frequency from coming from HMI. Okay. Click on programs and right click on it and click new file. Click OK. So our ladder diagram will open. Let us maximize this. So first of all, we will write network for DP-LS5 instruction. So how we can write for that? Let us zoom it. So first of all, we have to give input button. So as you remember, we have used X0. So you can just type from your keyboard LDX0 and press enter. So you can see our NO contact is created. Or what you can do, you can just select contact from here, bring your cursor to this red portion, and here you can write X0, whichever you feel easy. So first of all, you can go to help, click on PLC instruction and registers, go to search and you can write DP-LSY and hit enter. You can just write PLSY. So here you can see, first we have to write frequency, then we have to write the number of pulses, and after that we have to write the output. So let us minimize this. So here from the keyboard just write DP LSY. First is our frequency. So our frequency is stored in D2 register, and then number of pulses is stored in D0 register, and our output is Y0, and press the enter. Now, as I discussed earlier, by using this instruction we cannot change the direction. So if you want to change the direction, you separately have to use a network. So here we will write change direction, press enter. You can select contact and any input like X1 we have already used. So here let us use X2 for changing the direction for PLSY instruction. Okay. So here what we can do, we can just use on off coil. So just select this coil and give its address to Y1. So if Y1 will be on, it will give reverse direction, and if Y1 is off, it will turn in forward direction. Now we will see DP-LSV instruction. So in that again, let us take one NO contact. So we can take like this LDX1. Here we will see PLSV instruction. So you can see we can only give frequency, we cannot give number of pulses, but we have two outputs Y0 and we can write Y1 for direction. So that we will use over here. Just write DPLSV instruction space, and frequency we can give from D2 and our outputs Y0 and Y1. So if I write positive value of frequency, Y1 will be off, and if I write negative value of frequency, Y1 will be energized, so it will run in reverse direction. So this is the DPLSV. Now why I have written D over here? For example, if our number of pulses or frequency has larger value, so in that case we use D like double word or double integer. So like it is like that only. If we have less number of pulses and frequency, we can just write PLSY and PLSV. So for simulator, only this much code is enough. But as discussed in our presentation, if you want to use other instructions, so you can also use other instructions similarly only, like let us say LDX3, and then you want to use DPLSR instruction. So it has three inputs. So if you want to know what are these inputs, just you can write from here PLSR instruction, and you can see first is the frequency, then S2 is the number of pulse, and S3 is the acceleration and deceleration time. So here you can see it is 3000. 3000 means 3000 milliseconds. So that means 3 seconds. So there is the acceleration time of 3 seconds. So similarly here also we can write D2 is our frequency, D0 is our number of pulses, and here we can write like 5000. So that will be 5 seconds of acceleration and deceleration. So in this way you can write this. Similarly, if you want to write DDRVI instruction, just write DDRVI, and we can write number of pulses. Instead of data register, we can write like this only. Let us say, now what is the difference, main difference? Here observe that first there is frequency. Here also first there is frequency. But in the DDRVI instruction, so here you can see this is the DRVI instruction. Here first comes the number of pulses. Okay. Here what we have done, first there comes frequency. Here frequency. Here also first comes the frequency. But here in the DRVI, first comes pulses, then comes the frequency. Another change is in the DPLSV command, by making the frequency negative, we can change the direction. But in the DRVI instruction, if you want to change the direction, you have to give negative number of pulses. So this is the main difference between DRVI and DPLSV. Okay. So let me write over here DDRVI. Let us say we want to move 10,000 pulses at what speed? So let us say 500 hertz, and our output Y0 and Y1. Similarly, let me insert a network, and again I will write DDRVI instruction. This time I will write minus 10,000 at speed of 500. Minus 10,000 is number of pulses, 500 is frequency, and Y0, Y1. So in here it will run in forward direction, and this will run in reverse direction. So similarly we can write DDRVA instruction. So for that, here just write the A. You can see all the things are same. First there comes the pulses, then frequency and output devices. Here you can see just the difference is its working that I have already explained earlier. So right now we don't need this. For HMI simulation, just this much code is enough. Not even this is required. So let us delete this also. So just this much code is required for our HMI screen discussed earlier. So meet you in the next video where I will show you how to create HMI screen like that, and we will also see its simulation.